So I'm hitting the share screen.
Yes, sir. Quick introduction. Guys, again, welcome. Thank you very much for joining us. For those of you guys who don't know me, my name is Alex Dubavoy. I run the DevOps and security team over at Averity. If you don't know who Averity is, we are a staffing company in New York City specializing in certain areas, and we really value human interaction. So as much as we wanted to do this in person, we couldn't not do this. So thank you everyone for joining us. We're gonna do Q&As a little bit differently right now. So the way we're gonna do it is if you guys have a question for the speaker, throw it in the chat. And then into the presentation, Gadi and then Sarah will get to as many questions as they can. So again, thank you for joining. Without further ado, I give you Gadi Naor, co-founder and CTO of Alcide.
Awesome. Thank you so much, Alex, for having me. So for those, so I don't know like who of the attendees actually attended previous events. I'm assuming kind of there is some sort of rotation. So I had the opportunity to already do a talk with Alex. The recent one was at Namely Office downtown. So a little bit of background about myself. As Alex mentioned, I am a CTO and one of the founders of Alcide. Alcide is a company focused on security for Kubernetes and service mesh. And we are really good at actually bridging security and DevOps. By way of non-professional background, I love skateboarding. So one of my indulgence during this COVID lockdown and all that is breaking curfew and go skate in empty streets and all the places that I normally can't skate. So I did try to find kind of the benefits of this kind of bizarre situation we are all in. From a professional standpoint, I spent most of my career as a kernel developer, both Windows and Linux at companies like Checkpoint, mostly doing like VPN, firewall, and network security stuff. And at some point I got upgraded to user space. I'm thinking about it kind of to see the light. And when containers and Kubernetes became something, you know, very fascinating and adoption was pretty amazing and staggering. So this is where the point in time where we actually founded the company. So in today's session, I'm going to kind of, and I did see that there aren't many people here that are actually using GitOps already, but give you the lay of the land of the principles of GitOps. And hopefully it will give you kind of color and sense whether this is something that you want to pursue or this is something that doesn't really fit the culture, some challenges around GitOps, and then the unique security challenges that GitOps introduces as an operational model. So without further ado, let's dive into what is GitOps. So effectively, GitOps is a term that was coined by Weaveworks, which is a cloud native company, services company that engage on multiple projects. Multi-tenancy Prometheus cloud service is one of their projects, and GitOps is something that they are promoting heavily in the recent couple of years. And another parallel project to Flux, which is coming from Weaveworks, is Argo CD, and there are other projects that are coming to life. Argo CD is coming from Intuit. GitOps essentially is an operational model. It's the way that things are connecting people, processes, and systems and building applications. And Git is pretty much the source of truth. All the operations that we are performing around building and shipping and delivering our applications are starting and ending with Git at the heart of it. And there are benefits of using Git, especially for developers, which is their comfort zone. Git as a technology is not technology specific, which means that you can apply those concepts if you have a fully cloud native application that is based on Lambdas or other technologies. It just a concept of how we can leverage and harness Git for the purpose of leveraging some of the security features that Git offers in order to deploy and deliver applications into the target environment. In the majority, I mean, I haven't seen any companies that are actually using GitOps with like pure serverless, and Kubernetes is always part of the ongoing or the underlying platform that kind of is being match made with Git. But essentially, as I mentioned, it's pretty much technology agnostic. So I do believe that if GitOps becomes something more popular, then we will see this operation model engage with other types of technologies. And GitOps itself essentially is just set of principles or concepts, which we will dive shortly. And essentially it mirrors the state of what we see in Git into the actual state of the target environment. And specifically, I'm going to talk about Kubernetes, which is the most common use case for GitOps. So what are the 4 principles of GitOps essentially? The first one is that the entire system is described declaratively. Anyone who's kind of do the 101 on Kubernetes would kind of see the first thing that Kubernetes kind of adopts or put kind of the spotlight on having things built in a declarative model. Everything is described in configuration files, and then Kubernetes software, which are normally kind of controllers, will make sure that the declarative configuration will be reflected into the cluster, and the cluster state will match the expected or the desired state as it declared by the configuration. The canonical desired system state is versioned, which means that all the security features that we need, like audit trail and change management and workflows around with teams and everything, is really built into Git in a native way. And this is something that is quite core to the GitOps operational model, where we leverage this versioning to do rollbacks and pull requests to kind of approve things. And this motion is pretty much designed into that. Any changes that we approve as part of the Git repo is automatically applied or reflected into the system. And pretty much the last principle revolves around the fact that we have control loops that help us maintain this kind of mirroring between what's happening inside our Git repo and the actual state of the cluster. So any divergence of the cluster state, for example, with whatever is represented inside Git, is automatically reconciliated by those control loops. And this is an important property of GitOps agents, or the software that actually driving this concept. So it's kind of, think about it as like self-healing infrastructure that tracks whatever is pretty much articulated within the Git repo. So I think when it comes to the question whether GitOps is something that as a team or as a company or as a group of people is right for adoption, it's really about, first of all, culture. I mean, when you have everything revolves around Git and you want to, for example, engage security people and allow them to do their due diligence and share them with whatever is happening inside the engineering cycles, or providing them some visibility to what happened in the development stage, then we would need to have those security folks engage with kind of the Git tool stack. It's not something that, you know, is readily available or natural for the security stakeholders. So again, the cultural aspect of using GitOps is a really important aspect, whether this is something that makes sense for a company or a team, or not. The second element is that oftentimes CD, like continuous delivery systems, are considered to be broken, in quotes, from a security standpoint. And unlike Git, for example, that provides very strong mechanisms to push code with certain kind of conditions that has to be met, merging stuff into master and then reflecting this into the cluster, has to go through certain assertions and checks. So the notion of whether we want to have a push-based model to production versus a pull-based model for deploying stuff or delivering stuff to production is really a matter of again, a little bit of culture, a little bit of processes, and how exactly you ship software into production. So, for example, a very common practice in CD is actually having multiple clusters where you actually promote from one environment, like from test to stage, and then if stage kind of becomes green, then we can promote the assets to our production environment versus, you know, going and reflecting whatever is running in Git directly to production. So it's really a matter of how you want to operate the push versus the pull model that GitOps introduced. The other element is Kubernetes by itself is notoriously known as a black box for security teams, and the flexibility of the system itself is something that is not easily digestible. And the question is, like, when we are using GitOps, like how much, let's call it black color we're adding to this black box, and how much visibility we are adding to Kubernetes when we are moving into a model where deployment is being done from a Git repo. And the fourth element is, if we invested a lot of efforts in protecting our access, or at least having a well-defined access controls to our cluster, when we have something that runs under the GitOps model or spirit of things, access to the cluster is, I mean, if I have access to a repo, then I have access to the cluster. So the question is, like, what security mechanisms, and we'll dive more into that in the next few slides. What are the security mechanics that we have in place to kind of maintain the security boundaries and the security threat model and risk model that we have once we move into this model? And it's not trivial to kind of have an end-to-end kind of visibility into the entire workflows and processes, and actually consolidate, for example, the audit log instead of one system, which is Kubernetes, now kind of compose it from the Git audit log and Kubernetes audit log. So it's not straightforward out of the box. And again, the choice whether you want to use GitOps, I mean, this is the fact that this is new and cool is one thing, but you should really ask yourself, like, what are you losing by adopting this new methodology? So let's dive into kind of the security considerations that we have around GitOps. So a moment before we go into the kind of depth of what is it to secure GitOps and Git in order to serve us for operating our clusters, let's remind ourselves, like, some of the trust boundaries and risk boundaries that we have around Kubernetes itself. So Kubernetes itself has the management plane. If you are using a managed Kubernetes server, this is fully hosted inside your cloud environment. The API server, think about it as, I often like to refer to an analogy from the aviation, airports. I mean, it's not very kind of popular right now with all the Corona party that we are having, but think about the API server as the control tower that is responsible for making sure that, you know, airplanes, which are workloads, are taking the right paths and monitor them in flight. And if we think about before even the scheduling of workloads or pods into the cluster itself, we need to make sure, for example, about all the configuration checks that we want to have. For example, which pods are running privileged? Are we allowing anyone to deploy services of type load balancer, which basically expose the cluster to the outside world? Anything around RBAC privileges is something that we definitely want to take care of. So think about it as like all the pre-flight checks that we want to have as part of our environment. So if you think about the pre-flight, the in-flight, which is the runtime, network security and host level security and container level security, all of those challenges are not changing if you are moving into a Git model or GitOps model. It mainly changes the way that we bring Kubernetes configuration and introduce them into the cluster, as well as introduce changes into the cluster itself. So for example, one major change when we are moving into a GitOps model is that Git push can potentially become your kube control apply. So if we, for example, try to protect our API, access to our API server by, for example, building our Kubernetes cluster as a private cluster, or for example, setting a jump host or bastion host to allow access to the API server only from certain network locations, then this is something that completely breaks when we are moving to GitOps, pretty much because the GitOps agent, whether this is Flux, Argo, or D2IQ Dispatch, or Jenkins X for this matter, simply pull from your Git repo the assets into the cluster. So again, this is something that we are losing once we are moving into a GitOps model. Another good example, when we are running kube control apply, there is every operation actually goes through several steps. The first one is authentication. It's establishing the identity of whoever is trying to perform the operation. The second step is authorization, which means that we are checking against the policy whether the user is authorized to perform the operation that he would like to perform. And the rest of the steps are pretty much kind of admission controllers that may or may not allow the operation, and then the actual operation is being applied to the cluster. So when we change into GitOps model, the user attribution of API server calls is all of a sudden being performed on behalf of the GitOps agent. So if you want to track back like which users were performing which operations, then we need to make sure that at least the GitOps agent still propagate this information to the API server log as part of the impersonation properties that are kept by the Kubernetes audit log, or we need to consolidate and monitor the Git audit log itself, which is again extension of the moving parts that we need actually to cover from a security standpoint. So this is kind of two elements that are breaking really bad when it comes to moving into a Git-based operational model. And if we think about Git, your Git repo itself, so now it becomes a critical property and an asset that we really need to take care of in terms of security. I mean, it's not that we were neglecting that in the past, but now that because of the fact that we have direct path between our Git repo and our clusters, then essentially we want to make sure that we cover Git security in a much more diligent way than we probably had before. So for example, if we are having or we allowed kind of to have Git user impersonation, we want to make sure that we enforce identity, and we want to make sure that we have the identities signed. You can use like GPG signatures on the commits, or you want to have kind of a pre-receive hooks that validate the authentication of the users to make sure that only authenticated users or authorized user can perform those checks and their identity is valid. Pretty much because if we need to go back to the Git audit log, for example, we have a one-to-one attribution of the user in the event where we need to investigate. Anything that revolves around history rewrites, so for example, forced push to master that actually rewrite history is something that we want to completely avoid, because again, think about now, if any of you is kind of subjected to regulatory compliance, this is something that will break compliance, because essentially regulatory compliance mandates that you will have audit log for certain operations that are around the sensitive parts of your system, for example, cardholder data in PCI. Then rewriting the audit log is definitely something that you want to avoid. Disabling all the security features that as part of your Git provider is something that you don't want to, or you pretty much want to avoid. So for example, have your Git provider audit log turned on. Make sure that commits to master go through multiple kind of reviewers and anything. And again, this is something that really boils down again to culture. How do you want to map Git repos to your cluster? So there are several religions around that. One of them is basically say, you know, map a Git repo to a Kubernetes namespace, or you can have one Git repo per cluster, and then each branch basically represents, it's kind of mapped to a namespace. So again, you really need to tailor the workflows to how teams are structured and the interactions between them and the risk model around namespaces, whether you want to work kind of at the namespace level. So, and I don't think that there is kind of one answer to like a question, how should I work with my Git repos? You really kind of want to build it around the workflows and productivity of the teams. I will share that I had seen several customers of ours that actually adopted GitOps as their operational model, where if you do apply very strict security controls and around the development environment, then this is something that affects negatively productivity in a bad way. I mean, not having the ability to kind of deploy something freely to the cluster, or if RBAC permissions are limiting you, then this is something that you really want to avoid in the earlier stages of the development environment. You don't want to have like GitOps actually affect your productivity, your developers' productivity in a negative way because of the way that it actually works. So when it comes to like the GitOps agent, like the entity or the asset that is running inside the cluster and actually takes care of reconciling any deviation from whatever the source of truth is telling about the state of the cluster. Making sure, for example, that if a container image had been pushed to our container registry, which is another feature that GitOps agent provides, then the GitOps agent will update the cluster. So essentially, when we think about this operator that is running inside the cluster, that takes care of all the GitOps mechanics and machinery, we actually have a highly privileged component, a persistent one, that is running inside our cluster as root. And if you think about I mean, this is kind of pretty much the necessary evil. In some cases, you can run your GitOps agent on a namespace level rather than providing the GitOps agent a cluster-wide control. You can see here an example of how Flux is being installed into the Kubernetes cluster, and you can really see that it has got permissions on everything, which means that if this component is compromised for whatever reason, then this is game over as far as the cluster. One thing that at least I can relate to from a security standpoint is actually maybe going after a hybrid approach where you leverage GitOps agents to do all the application level stuff that you need inside your cluster. So for example, application workloads normally do not need any privilege kind of privileges to run normally. So they don't need to run as a privileged pods. They normally don't need to create load balancers. And if you keep your GitOps to serve only the applicative part of your cluster, and then the rest of the cluster infrastructure, like the monitoring stack, like if you're using Prometheus and the log shipping and the security agents are being managed and deployed in kind of a different way, or even leveraging different GitOps agent that runs on separate namespace, then you really have a balance between the blast radius that changes coming from the application builders that can introduce to the cluster versus the changes that are related to the platform itself. So this is one way to think about maybe of employing a hybrid approach where a platform team is running in a different style than the application teams. And again, if you think about Helm version 2, Helm version 2 has this bizarre component called Tiller that was basically running as an in-cluster god, and this is pretty much was kind of a broken part of Helm as far as security goes. So again, GitOps agents are not different from this perspective. I mean, there's certainly security mechanisms that are built into those agents, but essentially we have a persistent component that is running as root inside the cluster. I will say that in order to get a handle of the behavior of your GitOps agent, given the fact that it runs with God permissions, is to monitor your Kubernetes API server audit logs. And by doing that, you will be able, I mean, if you have like something that actually profiles the behavior of your GitOps agent, then an AI-driven component is something that will be able to detect breaches and anomalies that are associated with specifically GitOps agent, given the fact that its RBAC permissions are extremely permissive. Another way to kind of limit the blast radius that your GitOps agent requires is actually reducing the RBAC and tuning the RBAC policy manually. I wouldn't say this is kind of an easy task, but if you want to kind of stay on the least privileged side of the fence, then you can really kind of reduce the RBAC privileges of Flux and Argo CD for this matter in a nice way based on the actual activities that are taking place inside the cluster based on the applications that you are using. So if we kind of try to see this visually, so you can really see here that normally GitOps agent, whether this is Flux or Argo CD, will connect to your Git repo. You can have multiple repos, for example, one for configuration of the platform and one for the application. Developers would be able to kind of do their development cycles and do kind of the normal Git workflows, as well as monitoring the container image registry. And then based on changes that happen either in the container image registry or the Git repos, then the GitOps agent will propagate and reflect those changes through the Kubernetes API server, just like we see here. So again, the GitOps agent is pretty much running as a very, very highly privileged component inside the cluster. This is an example. So I picked kind of from one of our environments. a network visualization of how Flux agent, this is kind of real life example. And what should really strike you here is the fact that you have an in-cluster component that is running as root and has egress access to container image registries, Git repos, and anything that you know, your application is pretty much wired to do. And if you think about it from segmentation standpoint and security standpoint, Kubernetes network policies, for example, will not allow you to connect or enforce policies for this matter, because you need to kind of access locations that are outside the cluster. So again, even the runtime security of Flux requires security, I would say, solution that goes beyond the Kubernetes native offering by itself if you want to have a proper segmentation. And again, think about Flux as a component that can be leveraged by a threat actor or in an exploit situation to exfiltrate data, simply because segmentation here is something that you cannot apply using the Kubernetes native controls. So this is relatively kind of a complex diagram, but it really gives you lay of the land, at least in our universe, of how you can implement security under the GitOps operational model, and cover, I would say, kind of the three main areas, which is making sure that configuration, like the pre-flight checks, are covered, making sure that the runtime security is covered, as well as monitoring the Kubernetes API server and its audit log to make sure that you know, no one breach the cluster or stole kind of credentials, or even breached an application inside the cluster, which effectively allow the user to manipulate the cluster and change its state through the API server. So you can really see here that Flux, which is the GitOps agent, is responsible for synchronizing the state of your applications from the Git repo. And if you have a runtime security agent that monitors the network and even all the way down to segmenting the egress traffic, then this is something that we can really lock down the blast radius and the freedom that Flux, for example, have in this situation. The nice thing about Flagger is it's a component that monitors metrics that are available in Prometheus. And if you are able to reflect, for example, security metrics that reflects the state of the cluster after each and every synchronization operation made by the GitOps agent, we can really build a mechanism that can help us to do the following workflow. I mean, if someone pushes a change into the Git repo and Flux making sure that it applies this change into the cluster, then if we have a periodic scan of the cluster, and for example, the developer pushed a config map that contains a Slack token, let's take that as an example. So once the scanner is able to detect that there is a config map with Slack token, reflecting this into security metrics can be something that Flagger can pick as a negative drift and then roll back the state of the cluster to its previous kind of version based on the Git versioning system. So we have a really nice mechanism not only to have progressive deployments, but also progressive security. I will say that with Flux and Flagger, this is a relatively not straightforward combination, and Argo CD as kind of a nicer mechanism of sync hooks. So let's take a look at that. So this is an example of one of, again, coming from our universe. Alcide Advisor is a configuration and risk scanner for Kubernetes. And the nice part that you can see here is that Advisor can run as a job inside the cluster. And by leveraging certain annotations that Argo CD monitors, it will be able to run this job after in this specific case, this is a post-sync hook, and trying to make sure that this is kind of the last event that happens after the sync. So essentially, we want to make sure that the cluster is being scanned by a security component after changes are being applied, as well as rendering that is required to happen by Kubernetes. So for example, if I do deploy a CRD into the cluster and the CRD is picked up by a controller that, for example, spin up a privileged pod, then Advisor will pick up that there is a new privileged pod and it can fail the sync operation by failing the job. And Argo CD will monitor the job, and if there is what we like to call as a negative drift from a security standpoint, it will be able to roll back the cluster to the previous state, which is again equivalent to the previous Git version. So I think it pretty much covers the topics that I wanted to share today. I do encourage you to try some of the open tools that we have. They are on GitHub. We have open source tools for RBAC, Advisor, the Kubernetes security configuration scanner is something that you can really try. And there are examples in our Git repo to implement Argo CD sync hook. And again, if you are interested in more kind of deep security controls, like runtime security or security for your Kubernetes API server, then by all means, hit those links. So I think that I can definitely take questions here. So let me just exit the full screen mode. I'll keep it here on the screen. And let's see if we have some questions.
And you guys can unmute yourselves at this point. If anybody wants to ask a question, go for it. All right. Well, Gadi, thank you very, very much. Again, it's
absolutely
o'clock in the morning where he is right now. Thank you for joining us and giving up your sleep for us.
Super cool, Gadi.
Awesome. If anyone has questions, I'm going to stick around. I'll fall asleep on the bench here after Sarah's.
I won't be upset if you want to go sleep.
So Sarah, I do know that your talk will keep me kind of engaged. So I'm here.
Here's hoping.
Awesome. Gadi,
Awesome.
Thank you. If anybody does have any follow-up questions, just feel free to throw them on in the chat. Also, if anybody has any questions for myself or Chad and Danny on the Averity team, you guys all know what we do. Any questions on the job market, any questions on how we can help you, or just in general, if you want to say hello, feel free to drop me a line. But in the meantime, really, really, really excited about our next speaker, Sarah Duncan. She is a senior data engineer at the New York Times. And I'll let you take it away, Sarah.
Cool, thank you. Let me just share my screen. I think I have to be a host first.
Sorry about that.
Oh, you're good. Just I'll take the opportunity to plug Averity. They actually did get me this job at the New York Times and make that connection. So I'm very excited to be here. I'm very grateful to the Averity team, both for this opportunity and for getting me my opportunity at the Times.
Thanks, Sarah.
Absolutely.
Pleasure to work with. Your name comes up in the office often as somebody that everybody really loves working with. So.
Thank you.
All right, it's all you. I'm out of
All
here.
right. Thank you. All right. Well, as Alex mentioned, I'm Sarah. I'm a senior data engineer at the New York Times and the tech lead for the media innovations team in data platforms. I also chair the architecture review board, which is a group of engineers primarily dedicated to providing guidelines and feedback on software architecture. And so with those two interests in mind, I really wanted to share some of the pain points that my team's faced over the past couple of years. And as we're kind of building data platforms for the New York Times, and the takeaways that I've really gotten from those and how we've designed our latest solution. So just a quick kind of look at what we're going to be talking about. I'm going to give some background on our platforms and then go through some of the various pain points with our previous solution, how we address them in our new solution, and kind of the design consequences that entailed. Then I'll wrap up with the current state of our tool and leave some time for questions, of course. And just as a kind of a caveat, since we are doing a remote thing, my cat's currently asleep, but has been known to pop into these calls. So hopefully she stays asleep, but just as a heads up.
We're pet friendly. We're good.
Yeah. All right, so first a little background. So I started at the Times in 2018, and when I joined my team, we supported a platform that was used to manage data ingestion. It was a custom managed Apache Airflow environment running in Google Cloud Platform that used the Airflow Docker operator to run at least one Docker image per data source. This presented some pain points that we learned from, and when the needs for data ingestion greatly increased, especially for our marketing team, we took the opportunity to rethink how we wanted to approach data ingestion at the Times. So that's how Octopus was started, named as such because like this guy is using many arms to build, we use many arms of our system to simultaneously build and execute data pipelines. The question was just kind of where to start. So that brings me to the pain points and thinking about how we could address them. So the first major pain point that we decided to address was that there was a code base for each data integration, sometimes several. So it made the platform increasingly hard to maintain with each new integration, especially considering that separate code bases made it difficult to ensure that the same practice was used, let alone that a best practice was used across all the different integrations. Adding an integration easily took a couple months for an engineer. We usually only had the bandwidth to dedicate one. And given all the steps to understand the associated API and write a new code base that included authentication and rate limiting, data validation, formatting, writing appropriate data storage locations, it goes on for the different kinds of steps to a pipeline. And not to even get to like validating the results with the team who requested the integration, backfilling any data to the date that they needed. And on the architecture review board, we talk a lot about the value of easily holding a mental map of a system in our heads. It helps a lot with communication across the org, as well as just the engineering work itself. If it's simple to understand, you can hold the whole concept in your head. So that leads me to my first takeaway from building this new solution, which is that data is complicated enough, as I'm sure many of you can relate to. So it helps to keep our solution simple. And with simplicity in mind, we decided that to build one engine that could be reused across our data integrations was the best path forward for us. This engine would manage limitations on execution, such as rate limiting. It would manage the authentication, the simple data transformations, writing the data storages, all those steps that I mentioned previously. And by removing the nuance between these integrations, between these data pipelines for like the exact business need, by removing that and moving those into configuration files, we reduced the complexity of the engineering solution needed. This addressed our pain point by making the solution easier to maintain ensuring all of our integrations followed the same practices, being able to ensure that testing covered those practices, and reducing the engineering hours necessary for a new integration, and greatly decreasing the mental map needed for our solution. This last benefit, I talked a little bit about the general benefits earlier. It was especially important for this solution, given that it would not only be used by engineers, namely our team, but also by analysts. We have a large group of data analysts at the New York Times who are constantly generating reports and thinking about better ways to use our data. And with users such as these who are technical, but not as well trained or practiced in the same engineering concepts, an easy to understand solution was critical for ease of use. So then getting to the implementation, building a configurable engine sounds cool, but how are we going to use it? We didn't want to lose the benefits we were getting from Apache Airflow, like scheduled runs, visibility into those runs, easy logging, easy backfills. And it was already a familiar tool for us and our users. It's a very common tool at the Times, especially in data engineering. The good news was that at this point, Google Cloud Platform had Cloud Composer, their managed Airflow service, and my team was already familiar with it from other projects. So that part was easy. The bad news was that Cloud Composer, like anything, has its own pain points. Namely, spinning up a new environment can easily take an hour. And Cloud Composer is usually a couple versions behind the latest Airflow release, which for those of you who are a little bit less familiar with Airflow, it's not as easy getting an older version of Airflow running locally, because the dependencies for that version of Airflow aren't pinned. And the configurations you need to make aren't always clear in order to mimic how it's going to act on Cloud Composer. So these pain points made us worry that deployments and testing could be difficult if we kept everything in the scope of Cloud Composer, especially if an analyst wanted to test an integration locally, which is often the case. So to use the benefits of Airflow via Cloud Composer, but minimize these downsides, we decided to only use Cloud Composer to schedule calls to our engine and to publish the engine as a Docker image onto Google's container registry. This also made sense from a scalability perspective, because we didn't want to run integrations on Cloud Composer's Kubernetes cluster, since we have little control over it. Instead, we wanted to scale and manage our own auto-scaling clusters and run our engine on those clusters instead. So our scheduler pulls our engine's Docker image and runs it on our managed cluster using Airflow's Kubernetes pod operator. Though this did add another service to our solution, as you can see in the little diagram, in our case, maintaining the two more specialized services was actually much simpler than trying to satisfy all our needs in one service. And that's how we started with Octopus. So moving to our next pain point, the next thing we wanted to address was that inevitably one of our data pipelines fails. This is the case for every data engineer. And when that happened in our old system, once we fixed the bug, we had to start from the beginning of the pipeline. There were no stops or stop gaps during the run. And with some of the temperamental APIs we work with, these failures happened more often than we like. It's just one of the pain points of being downstream of these other systems. But what made it more difficult was we didn't necessarily know what the data looked like at each step in our pipeline based on the failed run. So that's how we learned our next takeaway, which is that audits aren't just for the IRS. Gathering as much information about each run without sacrificing too much performance is so helpful long-term, as it allows for better traceability through the system. With that traceability, we're now capable of checking if the data we're gathering is the right data, which is often a question that we kind of start to ask ourselves second, I find, as data engineers. We first ask, did we get the data? And then that second question is, okay, well, was it the right data? And this helps with that second question. So how to design for those audit checks. With Octopus, we really wanted to stage the data at significant points in the pipeline. This allowed us, for example, to fix a bug in how we're storing the data and rerun only that final storage step. as opposed to starting all the way back at the initial API calls. It also gave us better opportunities to check for any surprises in our data. And also, since we're on a managed cloud platform for most of the time, the outages that we can't control, being able to restart at a certain point because Google's cloud storage failed, as opposed to having to start all the way back at the beginning, was a huge benefit to us. So if our data fails at a certain, if our pipeline fails at a certain point and we wanted to check for that data, or if it runs and we want to see how that audit trail looked, we wanted to think about what kind of tool to use to check that data. If the data pipeline runs, how do I know if the data worked? The data is what I want. So that is where, to check the surprises in our data, we use a very handy internal tool called Snitch. And I think actually Brian Lavery is on the call and he runs Snitch. But when an Octopus run is finished, it makes a call to Snitch, which checks the data that we've pulled. We use it to check for the unexpected variations in our data and send an alert if one is found. This especially helps our analysts, as they're now alerted when new data might affect their reports. Like one of our analysts manages reports for how our marketing campaigns are doing on Facebook. And when marketing adds a new ad account to Facebook, which has campaigns, which then have statistics on the campaigns, there's a lot more data that can be gathered and used in reports. But before Octopus, the analysts had no way of knowing that account was generated because there was a failure of communication between marketing and the analytics team. That account could go on for weeks, maybe a month, and the data would just not be incorporated into the reports. And once our analyst discovered that there was this account, would have to go back and redo those reports and refactor in the data, re-pull the data to begin with. So by pulling everything we can and then adding these alerts on the metadata, we're really giving time back to our analysts, which is one of the huge goals of Octopus in the long run, is to make data easily accessible and make it very observable and see into what's actually happening. So that brings me to our next point, pain point, which was that we didn't have the resources to keep up with the data needs. I mentioned it at the beginning, but usually we only had one, maybe two engineers who could be spared to write a new integration. Our team's building a little bit more. We have open headcount, but new APIs to integrate additional needs from the data we already ingested, an updated API version. These were all things that used to take a lot of engineering hours. And we wanted to not only reduce the time we were spending, but the time that others were waiting for us to get the work done. Really like remove that silo from our team so that others could update the pipelines and it wasn't exclusively the 4 or 5 engineers who happened to be on the team at the time. So from that, I'll just say I may not embrace change, but I've learned that my solutions really should. If you ask any of the people closest to me, they'll confirm that I'm not the most graceful when it comes to change. But one thing that I've learned as a data engineer is that everything about the data we manage and transport, where it's coming from, how it's formatted, where it's going, it will all change at some point. And that's why we wanted to build Octopus, so that not only could it change, but it was actually expected to change. So how do you design for change? Well, really what this came down to is we wanted to be able to change integrations and extend features quickly and confidently. And I joke here about the solid principles, but to extend features easily, we really embraced that single responsibility principle and designed our solution modularly and defined contracts between those modules so that it would be easier when we needed to add a new option within a module. We knew this case would come up. Thankfully, it's really paid off. Since Octopus was launched into production last fall, we've added different kinds of pagination for our HTTP calls, whether it's you use a hyperlink to get the next page or you use a query parameter to get the next page. different kinds of data transformations. We get data in a whole bunch of funny formats and being able to flatten it into a solution that can be ingested into our final data storage. The final data storage changes, and adding new integrations. All these needs came up, and it was much easier to extend these different features. So that was one thing that really paid off. And this is also where our earlier decision to separate the engine that was running in Kubernetes from the scheduler that's running in Cloud Composer, where that came in handy again. Because since the engine was separate from the Cloud Composer environment, we could deploy changes to the engine over and over again, which includes our configuration files too, and not have to worry about Cloud Composer taking an hour to spin up before we can even move on to deploying it to production. So with our configurations easily deployable, now all we needed was to share how to use the configurations. But first, I just wanted to take a second to really, this is an example, this is the static model of Octopus. And it gives a little bit of an insight into how our different modules are working together, just going back to that single responsibility principle. And you can see that our orchestrator is what's coordinating the run, and it uses each module's capability when it's needed. So, you know, having your credential storage, managing how you're going to get things to authenticate. And one thing that we've actually been working on updating the past few weeks is you'll see right below the orchestrator, there's what's in this diagram called a context. And then the context is calling the executor, and we've actually moved the executor up so that the orchestrator is what's calling the executor. It's a little bit complicated, I think, when you're first getting into it, but once the names kind of are associated with a responsibility, it's much easier to think through as an entire process. So how do we share what those modules are doing? How do we share how to configure them? One thing that's a general area of growth for our tech org is that a lot of learning has been very word of mouth, and we're trying to adjust our culture a bit, but both finding out that a system exists and then learning the specifics about the software have historically been done by tracking someone down who knows about it. And it's pretty obvious why that doesn't work well with a growing organization, but we really felt the toll that this took on our time. And when a new engineer was onboarded or a new user was interested in using Octopus, they had to sit down with an engineer who had worked on it and go over how to write a configuration and what the different components meant and everything, which is not only a waste of time repeating the same information, but a couple days later, when that new member needs a refresher, there was nowhere to go to put that back together unless you went back to the same engineer. And knowing how we are as engineers, if we need to document our code because we can't remember what we wrote a few weeks ago, how can we expect someone with no baseline to understand the solution so easily? So that's what brought me to the idea of the realization how important it is to create a map and a key to that map for your solution. So adding to my list of takeaways, this is really important because going back to our data is complicated. Building that simple solution is the first step, but providing a guide for how to use that solution and the data that it creates, that's really the next part. So to help our users, especially the analysts we partner with, understand how to use Octopus, we've put together an extensive getting started guide and documentation outlining all the different configuration options. It's something we're improving with every sprint, but to make sure we address documentation, a few things that we're doing internally are including a PR template checklist saying have you added or updated the appropriate tests? Do the test run? And then have you added or updated the documentation that this change affects? This reminds us that we're not working alone, we're not working in the silo, and that documentation not only helps our users, but helps us in the long run, which is also where we get to documenting the changes that we're making for ourselves and for the more technical engineers who are looking at our system. We've really been working on documenting our architectural decisions with notes in every pull request for what the changes, the consequences, the alternatives considered, and why the solution was chosen, so that when we're reevaluating architecture decisions, we can go back and say, why did we choose that in the first place? So this way, we're not only iterating for our users, but also iterating for ourselves on our documentation. So those are some of the pain points. So just to wrap up with kind of the current state of Octopus and thinking about kind of like my thoughts on where we're going next. Currently, analysts use Octopus daily. We've integrated with at least a dozen different marketing partners. We have at least, I think we have a close to 24 different kinds of data pipelines that run. And we're expanding more towards being a platform not only for our group of analysts, but also more for engineers. So that brings me to the next steps, which are that we're improving our scalability. We are, I guess a note on the scalability, where since everything kind of runs as a direct acyclic graph, those steps are run as one call to our Kubernetes cluster. So in the past, everything's been so small that that's worked fine, but we're starting to work with larger data sets. So thinking about how we can separate those calls while maintaining the workflow so that we can really use Kubernetes scaling. Improving our configuration experience, because things make sense to us, but we built them. So really working with our users to build an easier way of building a configuration and improving that model. And finally, adding options to further support engineer users, because we've found that when partnering with our analysts, the analysts really they care about that end result data and care less about how it got there. And with the engineers who we partner with, there's a little bit of a separation of ownership in that they want us to own some of the platform pieces, some of the things we've already built, but they might want to run their own data transformation, or instead of calling APIs like we do currently, they might want to run a web scraper instead. So we're working on building out support to basically kind of host their Docker image and run their Docker image as like a step to our workflow. But that's kind of like how we're shifting and learning and growing forward. So that's it. I have a very small Twitter following, but if you're interested in tweets about the New York Times and food, there's my Twitter handle. And I will stop sharing and switch over to questions.
Awesome. Sarah, thank you so much.
Yeah.
Any questions in the chat?
I got one privately.
Go for it if you do. Sarah's cat will attack you.
Yeah, I was going to say to Sarah, what's interesting is that you talk about the engineers taking so much time to map out basically dependencies inside your architecture to be able to refactor, to configure, to upgrade, basically, right? How do you do? I mean, it sounds to me like you're doing it manually. Like you're basically asking people, what have you done? And let me document this for you, right? I mean, that's kind of like what it sounds like what you're doing.
I see. Thank you. I can definitely clarify. So what our team is doing is kind of like the investigation side of things when we're adding a new integration is mostly with the partner API that for whatever new partner marketing has or whatever the case may be. So that, for example, with Snapchat, like we have ads on Snapchat, and the way that Snapchat's workflow goes for their marketing API, and it's pretty common, is that you basically use your access token to authenticate your organization, and then you get all the campaigns associated with your organization, and then for each one of those campaigns you get an ad account, or the other way around, and then you get the ads, and then you get the statistics on those ads. So we are doing that programmatically, and we have a workflow that's generated. So basically our configuration file would outline those steps and say our organization's first, that's an HTTP call, and then we follow up with our ad accounts, then our campaigns, etc. And our workflow automatically takes the results of the previous task and spawns tasks for the next layer, essentially. And then as tasks are ready to run, it multi-threads those calls. That's why we have the rate limiter, to make sure we maintain our rate limit outside of the threading. And then when we get past the HTTP calls and can go more into internal tooling, it picks up even faster because we don't have the rate limit. So it's definitely a little bit like getting to know an API when writing the configuration file, but that workflow is generated automatically. Does that answer your question?
No, I get it. What do you do when you're just upgrading in general? You know, your apps that, you know, you must, at New York Times, you must have, you know, dozens and dozens of apps, both consumer facing and otherwise, that you're constantly forced to upgrade. And there are multiple dependencies that form in your architecture over time, you know, over different, you know, third-party integrations. How do you keep track of those, you know, dependencies as you build?
So tell me if I'm understanding your question correctly. Is it more around like
It's
as
more
the
around
third-party
DevOps,
APIs?
DevOps, which is to say, as you upgrade and modernize,
Mm-hmm.
how do you manage the modernization process by keeping track of all your changes?
Sure. So as we're making updates to our engine, the engine there's one Cloud Composer environment in production that's calling the engine. And so there's one image of the engine that's being used. And as we're making updates to the engine, we deploy that continuously to our production container registry. When it comes to dependencies, the configurations, the integrations that we have do depend on some modules working a certain way, but that's why we have the contracts, so that you can always expect that if you're calling this HTTP task, like that contract is going to stay the same. And how we make that called and how we make that HTTP request might change, but that configuration won't break when we make a change to the module behind it.
And are you asking more, just as a question, are you asking more of a generic question about how things are done at the time? There's something specific about what she's, about Octopus?
Well, yeah, I mean, I'm just understanding in general, a big organization like New York Times is constantly upgrading its technology, right? I mean, pure upgrading of the apps that are customer facing, you know, beyond what Octopus is doing. You know, how do you manage that process without breaking things?
Sure, it's a good question. And I can speak primarily from the architecture review board side in that case, that we take into great care when we're making an update to a production system, but especially when it interacts with other production systems. And that's why every new feature that could affect other systems, every new system that wants to interact with current production systems, that's why all of those suggestions come across the architecture review board's desk. So we have an internal RFC process so that not only is it the architecture review board's purview to provide guidelines on how the solution is being proposed, but it's everyone's responsibility to look at that proposal and raise any red flags that they might see. And there are certainly times when we fail, which I think is to be expected. But you know, as we fail, we have an incredible learning review process internally where we really think back to everything that could have gone better, everything that did go well, where we got lucky, and we kind of turn that around and think like, how can we do this better next time? So that those kinds of two systems of like checking with the org and with the architecture review board in particular, there are a lot of very close communications between teams that rely on each other. And then if there is a failure, we have an incident management response process and doing that learning review to follow up. That's really kind of how the...
Do you mind if I add something to that, Sarah?
Please, Brian, go ahead. Brian works with me.
We also use a lot, I don't know if this answers your question, but we use, for automation, we use drone. So we've got a lot of tests built into our pipelines so that, you know, as we upgrade things, did we break something? As far as unit testing, I mean, this is a DevOps group, so I'm trying to think of stuff that you guys would be more interested in. And I'm trying to think of others managing other dependencies. Well, we're also obviously some of the things we've been moving to more Google managed applications too. So we don't have to worry about certain things that if it breaks, it's their problem.
Which has its own problems.
What's that?
Which has its own problems.
It has its own downside. Yes, things go behind the curtain and then you're like, oh, no, what the hell is happening?
Right. I mean, the only reason I'm asking is because I'm a huge consumer of New York Times digital news, you know, and it's the best there is, and there's something that you're doing right, you know, to completely, you know, redo it. You do new releases probably every 3 months. You know, it's kind of interesting to find out, how do you do it?
Yeah.
What do you do?
Yeah, there are a lot of releases. I actually think we err a little bit more on the side of releasing more often as opposed to like less often. Like we try really hard to make our systems in such a way that we're not scared of deploying, and I think with varied success. But there are also, I mean, everything goes through intense like checks before it's released to production. The other thing we think about, we have a dedicated delivery engineering team, which is great. Which is huge because that essentially is our DevOps group. They manage our DevOps, they are like our developer support, and they're incredible. So many tools for us, and so a lot of stuff just works out of the box because of our DevOps, because of our delivery engineering team. And they also, the delivery engineering team, along with some product people, lead resiliency, a resiliency group. It's often especially focused around elections because with the election nights, I think with the past midterm elections, we had, what was it, Brian? Like more than like 2 million concurrent like readers at any given time, like checking poll data. Yeah, it's crazy. Yeah, and so we're constantly thinking about and doing like crazy resilience checks on our critical systems as we're leading up to major events like that, where we're expecting a lot of readers to be coming and visiting our site and visiting our apps. So they do a really incredible job. They make it look easy. This might be an idea for another meetup, but we could try to get someone from
because he's interested in also the apps and things like, whether it's the website or the apps, iPhone and Android stuff, and how do they handle that stuff without breaking things too.
Exactly right.
That would be awesome.
Yeah.
That'd be awesome. Any other questions?
Thank you.
All right. Then Sarah, thank you so very much. That was awesome.
Absolutely. Thank you for having me again.
I think it's really important for DevOps engineers to really understand the challenges as to what data engineers are going through, because everybody's working together trying to get the business running, the company running, whatever scale that you're at. So it's really important to understand perspectives in that. So thank you very much. That was really, really valuable. Does anybody have any overall questions? Anything at all you want to fire off at me, Gadi, Sarah? Fire away, guys. If not, we'll call it a night. Last call for alcohol? Anybody?
I got the alcohol already. I just want to thank both of the presenters, Gadi and Sarah. Thank you for your presentation.
Absolutely. Yeah, I already uploaded the slides, so I'll share the link here and also in the meetup group. So I'm sure Alex will email those as well.
Yep, and I'm going to share the video with everybody so we can stare at our little Brady Bunch tiles and all enjoy them. Everyone, thank you very, very, very much. I genuinely hope that we'll all be in person for the next one or in 2 months or whenever we can. Gadi, come on back down to visit. We'd love to.
I used to fly every other week, so I think that the relaxed flight schedule is. I'm okay with kind of not flying every other week. Happy to come back to New York, but yeah.
We'd love to have you. And really, thanks to all of you guys. We're almost at 2,000 members, which is amazing, and that's thanks to the awesome presenters and the people that come to the events, join the events online. And I promise, and when I say I promise, I mean it, as soon as we can have them in person, we will. I just want to make sure we're not breaking any rules and doing everything legit. So everybody, thank you very, very much for joining us. I hope you got a lot out of it. In the next 24, 48 hours max, I'll post the videos, I'll get everyone's slides. And everyone, thank you very, very much again for joining us. Gadi, get some sleep.
Well, yeah.
Working on it. Thanks, guys.
Thank you so much.
Thanks.
Stay safe, everybody.
Great night.